welcome to solving triangles using the cosine rule. And the first question is, what does it mean to solve a triangle? Well, to solve a triangle means to find out all the unknowns. So, you find out all the side lengths and all of the angles in the triangle. So in this triangle, let's just, first of all, before we obviously can't solve it because we're given no information about it at all. But if we kind of get to know what this cosine rule says, and the cosine rule almost feels like Pythagoras in some ways, but like a more advanced version of Pythagoras. So let's take kind of the angle that we're interested in as this angle. So what the cosine rule says is this, we got angle A and we got this side A on the other side. So A squared equals, and then we take the other two sides that were next to it. So this one here feels like the area. Remember the area rule we looked at that side. So we went C squared, and let's add this side here, B squared. So do you notice that we've got this angle that's in between these two sides, just like we had for the area rule, C squared plus B squared, and then we subtract 2C, B in this case, and then it's the cos rule, cosine, cos, so cos of angle A. So again, it's this idea that I want to sort of, well, if we've got this angle and the side that's opposite, so the angle, we look at the two sides next to each other. So this squared equals, well, this side squared equals, the angle is that one there. I'm saying this badly, but there's our angle there, right? Angle A. So we can look at the two sides that are either side of it. So we're going to square those, we're going to add them, and we're going to subtract, multiplying them together, cos the angle in between. So we could do that with any of the sides in our triangle. So if we went backwards here and went, okay, so let's rewind and say, what happens if the original angle and side we're interested in were this side here at B? So that means that we're looking at B squared, and we're going to have cos B right at the end. So we're going to that minus 2. So the bits of the puzzle we need to figure out are, well, that side is C squared, and we're going to subtract it over there, and the other one is this one here, so that's A squared, and we're going to subtract it there. So in this case, B squared is C squared plus A squared minus 2CA cos B. Okay, so let's use it in action, and we'll see what we mean by this. So here's our triangle. Quick pause breather so you can get it. Let's move out the way. Pause breather so you can get it down. Okay, cool. So you've got your triangle down. Now, do you notice that we've got this angle? Here's the angle. We've got it in between two sides. So it's like a side angle, side type thing. And we're trying to find out what the length of this opposite side is to start with. So that kind of tells us that cos rule is probably going to be the one we use, because we've got the included angle and we're trying to find the opposite one. So we go B squared equals, and then we just take the other ones. A squared, or the side names don't matter, that side squared plus this other one squared. And we're going to subtract 2, multiply them together. 12 multiplied by cos of the angle in between. So there's kind of our rule. That squared is that squared plus that squared minus 2, that times that, cos of that. Cos rule. Okay, so clearly if we want B, then we're going to take the square root of that whole thing. So, of course, our beloved calculator comes out, and we look at that to go, well, B squared, so B equals the square root of 10 squared plus 12 squared minus 2, 10, 12, cos 65. What do you get? What is that check? You're just going to watch me punch in the calculator. No. So equals, and we get 11,94. Today, let's go for 2 decimal places. Why not? I'm sure you rounded off to 12 after I've been rounding off, but that doesn't really matter. So, 11,94. Let's double check my rounding. Because I made that mistake the other day. I'm like, let's check. Okay. So there it is. Now, if we want to solve our triangle, it means we need to find the other angles in the triangle. So let's go for this angle here. And I think you could use cos rule again, because you could go, this squared is this squared plus this squared minus 2, this, cos that. But sine rule's generally going to be our easiest option, because we've definitely got all 3 sides and we've got an angle. So if we're trying to find angle A, well, angle A is this and relates to this one here. So we know that sine A over 12 equals sine B sine, what was that one? 65 degrees over 11,94. And so you can find angle A, because you're going to go shift sign and blah, blah, blah. So what do you get for angle A? Well, angle A, I get, let's see, I don't know, calculator comes out, and I go, well, I'm going to go shift sign, and let's see, we've got sine 65. And if you did this in 2 steps in the calculator, no problem at all, as long as you didn't round off along the way, times 12 equals 65,62. 65,62, did I say, degrees. Okay, so that out the way. So we've got 65,62, and therefore we can find out what C is, and well, we can just use angles in a triangle for that. So where can we get it? Just this side of my head, right? C equals, and what's your value of C using sum of angles in a triangle? Well, I don't know what I got. I haven't got there yet. Let's see. Zoom, that one there. And so I'm going to go 180 minus 65 minus 65, 62, right, equals 49,38. And let's just double check that our triangle makes sense. Is the smallest side opposite the smallest angle? Is the biggest side opposite the biggest angle? Well, let's just put this in, 49,38. That looks like the smallest angle, smallest side, biggest angle, biggest side, medium. Okay, so that's our faces angle. Second example, let's say we're given side. And let's go for 7, 4, and 9. Pause, jot down your diagram. Cool, so you got it done. And let's start with an angle. Now the question is, which angle do we want to start with? Now we have got this big angle over here, and we got these 2 smaller angles over here. Let's start with our, what should we go for? Let's go for our smallest angle, or our biggest angle, or our medium angle. I don't know. Which one do you want to go for? So let's maybe label these things. That's X, that's Y, and that's capital Z. Which angle do you want to try and find first? And why? Okay, so, the thing that we have to worry about is just some sort of, maybe is there going to be an ambiguous case where we're trying to find an obtuse angle and then things end up wonky. We know that in our cos diagram, CAST, cos is going to be positive in the first quadrant only, so I reckon we go for our smallest angle over here, which is going to be over here. Let's see where it gets us. Let's put it with a different color though. So we've got, that's a T, and let's go here. So man, just not working with me today. Okay, so let's go for that one over there. That I'm really not winning with my colors. Let me just fix my colors. I'll be back in a second. So let's do that. Okay, well, that was so weird coming back and forth, but those colors were annoying me a little bit. So, okay, now they all match up nicely. And we had said we're going to find the smallest angle first. Let's see where it gets us. And maybe we'll change our mind, maybe not. So, if we want to deal with this, then we're going to go that squared, that squared. So, we're going to use our cos rule. So, we're going to have that one. Now I'm getting in the middle, which is which again? So that's to that one. So we're going to have cos x at the last bit, which means we must be dealing with x squared equals. So just to make sure those match. So equals that squared. So the 7 squared plus 9 squared. That was right. That's right. 9 squared minus 2, and then subtract those. 7 and 9. So that's our cos rule. Remember, it's that angle there, so it's that squared plus that squared minus 2, that times that minus cos of the angle in between. Now, there's just one thing we don't know, cos x. So if we rearrange things, so let's just think through this rearrangement. Maybe just interesting to know, how confident do you feel? And maybe try and do it and then respond with your confidence level of just rearranging this equation so that you've got basically cos x left on this side equals something on this side. How did you get on doing that? Because you're going to pause, you're going to try it and then respond how you got on doing that. Okay, well, as always, interested to see maybe a good insight for there, because you've got this 4 squared, and maybe you're doing it on your calculator as you're going along. So you're going, okay, well, I've got the 4 squared on the left-hand side. I need to subtract the 7 squared. I also need to subtract that 9 squared. And so perhaps you did that and then went, cool, the calculator can hold on to that. I'm left with minus 279. So I need to divide by minus 2 times 7 times 9. And you got 19 over 21, or that 0,90, etc., etc. 0,9. Okay. Does that seem about right? 4 squared minus all of that. So there was cos. Now, cos is positive. This kind of makes sense that we're going to have an acute angle for this smaller angle over here. So now we're going to go shift cos of that answer. And we get 25. I'm going to go for no decimal places just so it's easier to do with. X equals 25 degrees. That's 25 degrees. Okay, now from here we could use our sine rule again, because we've got this over this, there's this over this. And so we could use our sine rule, or we could use our cos rule. Cos rule just feels more complicated to use than the sine rule. So with our cos rule, let's just do it because I want to do one more where we practice, and maybe you had started with the biggest angle. So let's do that. I'm going to move here. I can cover that up and get rid of the calculator and say, well, if we didn't know this 25 yet and we started with y, so what we want to try and find is the size of y, then we're going to go 9 squared equals, so this squared equals this side squared plus the other adjacent side, this side squared, minus 2 times those two things. This side times, now my things are getting in the middle, that side times cos of the angle that's between it, which in this case is y. So the y matches with the 9 that was on this side here. Okay, so there we go, and we could rearrange this all, and we could get, therefore, cos y equals, and again, maybe you just do this step by step on the calculator, and we're going, okay, so we've got 9 squared, we need to subtract that 7 squared and that 4 squared. Okay, let's just take it in from there so far. Then we need to divide that by minus 2 times 7 times 9. And we get minus 8 over 63. You know what, I'm just going to write it as minus 0, 1, minus 0, 1, 2. I'm not rounding off, just saying for that. So therefore, y equals, and we're going to go shift cos of that. Now, just as a reminder from our cast diagram, if we've got CAST, cos is negative, so it would imply that we're in the second quadrant. In other words, that the angle we're working out is obtuse, which does indeed match our triangle, because look, that's an obtuse angle. It's greater than 90 degrees. Okay, so let's put that in the calculator to get and go. Okay, so shift cos of our answer. But remember, we have to be careful because we want shift cos of negative our answer to get our reference angle, and we want to go 180 minus what we got there. So let's just rewind what we did over there. Let's go equals, maths error, that's fine. So we were over there. So this is a negative value. It doesn't really matter for cos, but remember for our reference angle, we always found it of the positive. So if we went just times minus 1, that was that's the next step already. 82, and we went 180 minus that, we get 97 degrees. Now, if you didn't do the minus thing on that, that's fine. As long as you get 97 degrees, and that's our angle over here, which seems to match the picture. Also, when we check it later, it'll make sense that we've got our smallest angle, smaller side, our biggest angle, bigger side, and then we can just use angles in a triangle to find our last angle. So what is the last angle in our triangle? Well, you know, me, I like to just check it on the calculator, and may as well, just in case we make a mistake in our heads, 180 minus 25 minus 97, 58 degrees. And that kind of matches our picture to go, well, the middle angle of the middle side. That's using our cos rule. So just once you get into, you'll get into the flow of using that. So yeah, carry on with the next exercise. We'll do heights and distances in the next one. So I think we need to finish off with some of that nice music, right? Just let me